Hello everyone, welcome to Sangam tutorials, Gubbi online classes for Ncert, SSLC and Cbse for mathematics and science classes. So in the last session, this is the 44th session. So in the last session we have discussed regarding the concave mirrors, its ray diagrams, image formations and the uses of concave mirrors. So this was the very important topic what we had covered in the previous session. So in this session we will be going with the convex mirrors, its related to ray diagrams and the uses of convex mirrors along with the mirror formula and magnification. So this is the very important topic in the entire chapter of light. So I hope you are all learning well. You have understood the previous concepts. So at this moment I would like to recapitulate the things connected to the concave mirror and we will move on to the convex mirror so that no confusions are there. Right. So regarding the concave mirror, so it is called a converging mirror or a convergent mirror. So in this concave mirror, we see that the outer surface is silvered so that the inner surface is highly reflecting. So when the object is placed at infinity, the image is formed at the principal focus. You have to remember this. Second point is when the object is placed beyond C, that is not at infinity, not at center of curvature, it is beyond C, just behind the center of curvature, the image is formed between the principal focus and the pole of the mirror. Right, that image is diminished. That image is diminished. It is real and inverted. So when the image is kept at the center, the object is kept at the center of curvature, the image is also formed at the center of curvature of same size, which is inverted and real, that is real and inverted. So when you keep the object between C and F, the image is formed beyond C, which is enlarged, right, when compared to the size of the object. So it goes beyond C. So it is the image is formed beyond C. Image is formed beyond C. And the next thing is when we keep the object between C and F. Between C and F. So here between C and F. Next is at F. Exactly at F. The image is formed too far away from the center of curvature. It is formed at infinity. That's very important because the two light rays which are traveling parallel to each light rays, when they travel parallel, the two light rays, we mean that they are going to meet at infinity and the image formed at infinity is highly enlarged. And when we keep the object between P and F, that is P and F, principal focus and pole of the mirror, this is very important. The image is formed behind the mirror, which is virtual and erect, and that image is a diminished one. So this is the very important topic, very important ray diagram we have to remember. So based on this, we have two characteristics of a concave mirror. One is concave mirrors can form real and diminished images. Concave mirrors can form virtual, erect and diminished images. So these two properties, characteristics of image formation by concave mirrors you have to remember. Once again I will recall this. The image is formed by a concave mirror or real and diminished, real and enlarged, the real and highly enlarged, and the image is formed by a concave mirror is virtual and erect, diminished. Virtual, erect and diminished. So concave mirrors can form two types of images. Very important. So when we come to the uses, most important uses we have discussed. So it is used as shaving mirrors. It is used in particularly it is used in making scientific instruments. So it is used as a very important. Concave mirrors are extensively used in reflectors, that is solar furnaces. So 3 to 4 uses we have discussed in the previous class. So in today's class we will be going with the most important another type of mirror, that is convex mirror. So let us remember what is a convex mirror. So it's a part of a hollow spherical mirror in which it's a part of it. So its inner surface is silvered so that its outer surface is highly reflecting. So I will just go with a simple diagram. So if this is a convex mirror, the inner surface is silvered. Its inner surface is silvered so that its outer surface is highly reflecting. It is silvered surface. It is silvered, and this surface is reflecting surface. You have to remember this reflecting surface. So this will be the pole of the mirror. So this will be the center of curvature of the mirror. So when you draw the line joining the center of curvature and the pole of the mirror and extend it on both sides, this forms the principal axis. This is the principal axis. So whenever light rays are made to, okay, let it be the principal focus. So when the light rays fall on the mirror or incident on the mirror parallel to principal axis, these light rays are going to get diverged, because after reflection they are going to get diverged in this direction. But it appears that these diverging light rays are starting from the focus of the mirror. So we have to draw it by the dotted lines because they are virtual light rays. So the image is formed at this point. So these light rays in this mirror, the light rays which are falling on the mirror as they are getting diverged in different directions. Therefore, this type of mirror is also called as a divergent mirror or diverging mirror. So this is the basic thing you have to remember here. So this becomes the center of curvature, principal focus, pole of the mirror. So this becomes the aperture of the mirror. The maximum surface of the mirror where the incident light can fall on it is called the aperture. So this is the principal axis. You have to remember everything. So these are the incident light rays falling on the mirror, getting reflected. But these reflected light rays appear as though they are starting from a point on the principal axis, and this point where the diverging light rays appear to start from, it's called the principal focus. So usually the distance between P and F is called the focal length. This is the focal length here, which is indicated by small letter f. So this is the basic thing you have to remember before we enter into convex mirrors. Right. So in a convex mirror, the formation of images is only of two types. When the object is kept at infinity, when the object is kept at any point in front of the mirror. Only two positions of the object is taken here. So therefore only we have two ray diagrams. So totally on mirrors we will be having 8 ray diagrams, 6 on concave mirrors and 2 on convex mirrors. So in convex mirrors only 2 ray diagrams. I repeat this. One is when the object is at infinity, that we will see that, and second one is the most important, very important, which is usually asked in your examinations, when the object is kept at any point in front of the mirror. So usually in case of concave mirrors we used to particularly mention where the object is kept. So we used to say at infinity, beyond C, at C, between C and F, at F, between F and P. So these were the things we used to discuss. But in case of convex mirrors, only two position of the object is to be taken. One is at infinity, another is at any point in front of the mirror. So both the ray diagrams we will go with. Right. So we will go with the first one, at infinity. So what happens? How the image is formed in a convex mirror when the object is kept at infinity. So now let us go with the mirror. This is a convex mirror. So it is silvered at the inner surface so that it is highly reflecting at the outer surface. So this will be the pole of the mirror. So this is the center of curvature. This is the principal focus, which is indicated by F. We will join all these 3 points and extend that. We will extend this in this direction also. So this becomes the principal axis, which is passing through all the points. So here, let the object be at infinity. So let us take this object, let it be at infinity. So here, the light rays coming from the object which is kept at infinity, let us take this as incident light rays. They are falling on the mirror. So we will take another light ray, because to mention in any ray diagram we have to consider 2 light rays. Minimum number of light rays required is 2. Therefore I am taking 2 light rays. So one of the light ray is incident on the mirror at this point. That is, let us take it as AB is one of the incident light ray. Okay, let us take PQ. Okay, let us take MN. MN as another incident light ray. So when they fall on the mirror, so we know the basics. These light rays, when they fall on a convex mirror, they are going to get diverged. So the light rays are going to get diverged here. So this is the diverging light ray. So here it is the diverging light ray. So after reflection it gets diverged. But if you stand at a point on the principal axis, and look at these diverging light rays, they appear as though they are starting from, these light rays appear as though they are starting from this point. And this diverging light ray, as though it appears as though it is starting from this point. So therefore, we assume that the image of this object which is kept at infinity, its image is formed at this point on the principal axis, that is at focus. So this is the image formation of an object which is kept at infinity for a convex mirror. So now, so here point number 1, where is the image formed? Image is formed at focus. It is formed at focus. So what is the characteristic of the image? It is highly diminished. So it is highly diminished. It is highly diminished. So third point. So what is the nature of the image? So whether it is array, whether it is real or virtual. So we know the rules of formation of an image. If 2 light rays meet at a point, and after reflection from the mirror, we say that at that point a real image is formed and it is inverted. So I will repeat this. If after reflection from a mirror, if the 2 light rays actually meet, really they meet at a point, then the image formed at that point will be a real image, and real images are always inverted. But in this case, these 2 light rays after reflection, they are diverging. They will never meet each other after reflection. But we assume that these 2 light rays are starting from this point on the principal axis. So therefore, here we assume that these light rays are starting from this point. Therefore, we take this point as where the image is formed. So therefore, these type of images will be virtual images. So virtual images are always erect. Virtual images are always erect. So formed at the focus, that too particularly is behind the mirror. Okay. So this is very important. So what happens when the object is kept at infinity in front of a convex mirror? So in case of a convex mirror, when the object is kept at infinity, the image is formed behind the mirror at the focus. Behind the mirror at the focus, it is highly diminished, virtual and erect. So this will be a 1 mark question for you. So what is the nature of the image, or write the characteristics of an image when the object is placed at infinity in front of a convex mirror. So in front of a convex mirror, when we keep an object at infinity, the image will be formed behind the mirror at the principal focus. It will be highly diminished, which is virtual and erect. If it is erect, it is virtual. If it is virtual, it is erect. So one concept is with you, that is, if you know that the image is virtual, no doubt it will be erect. If you know that the image is erect, 100% it is a virtual image. So vice versa, both are same. So this is what happens when the object is kept at infinity. So we will go with the second thing. Second point. At any point in front of mirror. At any point point in front of mirror. At any point in front of mirror means what? We are not very particular about it. We can place the object at any point in front of the mirror. It is beyond C, it's okay. At C, it's okay. It's in between C and F, it's okay. It's at F, it's okay. Between F and P, it's also okay. You can keep the image object wherever you want in front of the mirror. Same image formation forms when the object is kept irrespective of the position of the mirror. It can be kept in any point in front of the mirror. Okay. So we'll take a mirror here. We'll take a convex mirror. So we know that it is situate at the inner surface. So this is the pole of the mirror. So this becomes the center of curvature. So the point which is the midpoint between the pole and center of curvature is the principal focus. Let us join all these 3 points and extend it on this side also for reference. So this is the principal axis. Okay. So now let us place the object anywhere in front of the mirror. So now let us place it anywhere, somewhere here. Let us take it here. Let us take the object as AB. So AB is the object. So now here when we place the object in front of the mirror, anywhere in front of the mirror, it's left to you. Let us take 2 rays to define how the object is formed, image is formed. So let us take one light ray from point A. Let it travel parallel to the principal axis. Parallel to the principal axis. So after reflection, it is going to get diverged in this direction. So this is one of the point. Second one is we can take it anywhere. You can take it to the pole, or you can direct that light ray towards the center of curvature. It's left to you. So I will take it to the pole itself. So let another light ray hit the pole of the mirror, be incident on the pole of the mirror. So we know that any particular light ray, when it is incident on the pole of the mirror, it is going to get reflected at this point by using the loss of reflection. That is the angle between the incident light ray and the principal axis, that is angle of incidence, will be equal to the angle of reflection. So here, this particular light ray which is getting reflected here, right, let us draw it backwards in the backward direction. Let us take it in the backward direction. So now this diverging light ray, it appears as though it is starting from the focus of the mirror. So we will draw a light ray here through the dotted lines. So here these 2 virtual light rays meet at this point, at a point between P and F. It meets, that is, the 2 light rays after, in the sense, the 2 virtual light rays meet at the point behind the mirror. So this will be the point where the object is formed. So let us take it as the image formation here. So this is the image form. So let us call this image as A dash and we will call it as B dash. So this is where the image is formed. So what is the nature of the image which is formed? So here one is formed between P and F. So the image is formed between the principal focus and the pole of the mirror and the principal focus. Second point is, so it is, we can also mention it as behind the mirror. Behind the mirror, very important. Is found behind the mirror. So what is the nature of the image? It is diminished. It's not highly diminished, it is just diminished. When you compare the size of the object with the size of the image formed, so here the size of the image is, when compared to this, it is diminished. So it is little bit diminished, it appears little bit smaller than the size of the object. So third point is how it is actually. Is the image formed by actually meeting of 2 light rays or whatever it is. So here the image is formed after the meeting of 2 virtual light rays behind the mirror. So therefore it is a virtual image, and virtual images, as I told you, they are always erect. They are always erect. So this is very important, very important in case of convex mirrors. So based on this property of convex mirrors, many devices are being designed. So this is the concept behind all the uses of convex mirrors. Okay, we will go with the uses of convex mirrors. So one property of convex mirror we can make out here. So convex mirrors can make only virtual, erect and diminished images of the object which is kept in front of the mirror. So only one property we have here. So at this moment we will compare the characteristics of both the mirrors. I have concave mirror, another is convex mirror. So in case of concave mirrors, the images formed will be real, inverted and diminished, and also the real inverted images will be highly enlarged also. So first point. Second point of concave mirrors is, in case of concave mirrors can also form virtual, erect and diminished images. Virtual, erect and diminished images. Virtual, erect and enlarged images. So that is regarding concave mirrors. Once again I will repeat. Concave mirrors can form real, inverted images along with diminished and enlarged images which are real and inverted. Second point is, concave mirrors can form virtual, erect and enlarged images. Virtual, erect and enlarged images. When you come for convex mirrors, in case of convex mirrors we have only one type of images which can be formed, which is virtual, erect and diminished. Here we have virtual, erect and enlarged in case of concave. In case of convex we have virtual, erect and diminished. It is enlarged, it is diminished. So these are the two major differences between concave mirrors and convex mirrors. So these are the two ray diagrams. You have to practice this ray diagram very well, because this is going to be asked in your examinations, because it is very, very important. Let us go with the uses. So in case of uses of convex mirrors, very most important use of convex mirrors is they are being used as a driver's mirror, as a rear view mirrors in vehicles. This is the most important use of convex mirrors, which were extensively in the examinations. The question is being asked on this particular topic. Right. So before getting into that, just I want to give you an important point you have to note it. So here, let us take a plane mirror. So it is silvered at the top. Let us take a convex mirror, which is silvered at the inner surface. So this is plane mirror, and this is a convex mirror. Right. So let us take a point here, which where it's a source of light something. At the same angle, we will take another source of light here. So this is the source of light. Let us call it as point P. So now, let us imagine the light rays from this point source of light, maybe a bulb or a candle, whatever it is. So we will keep it here. When light rays fall on the mirror, they are incident on the mirror, right? They are going to get reflected. The light rays are going to get reflected. So if you draw a normal at this point, the angle of incidence will be equal to angle of reflection. So if you draw a normal at here, angle of incidence will be equal to angle of reflection. So this is what happens. So here, when we take the area covered by this light rays, that is reflected light rays, what they are coming out, the area covered by this, let us take an imagination here. So now, let us go into the convex mirror. So at this point, two light rays are made to fall on this mirror through the source. So here, the light rays after reflection are going to travel in this direction. Okay, here it gets reflected, it travels in this direction. So here, when we take the distance between these 2 points, we can easily analyze. Here, the light rays after reflection in case of plane mirror, the the distance covered by the mirror is very small. That is, the distance between the reflected light rays is very small here. So in case of convex mirrors, when the light rays from a point source, when they fall on the convex mirror, they get reflected, they cover a wide range of area, because the mirror is totally a convex mirror. As it is a diverging mirror, it covers a large range of area. For example, if it is some 10 meters or something like that, so it will be some 30-35 meters here. So here it's just an example for it. So here a very small area is being covered and a very large area is being covered, and the image which is formed here, if you take it as the pole, the image will be formed behind the mirror somewhere here. So that image will be, as shown here, will be virtual and erect. This image will be virtual and erect, which is formed behind the mirror. So in case of convex mirrors, because due to this property of a convex mirror, that is due to this property of a convex mirror, these mirrors are extensively used for making rear view mirrors in vehicles. For example, this is the mirror. I am driving my car. This is the mirror. This is the rear view mirror. Behind me, I have an object. Behind the car, I have an object. So I cannot look back while driving. I cannot look back and see which are the vehicles coming, or I cannot see the traffic behind me. So therefore, I use a rear view mirror here. So in the rear view mirror, when I see an object behind me, if the object is AB, inside the mirror, the same object, that is the full size of the object, is very important. Full size of the object can be seen as a diminished image which is erect and virtual. So as the object is, this is the size of the object, but the size of the object is very much reduced inside the mirror, so that I can get a wide field of vision. That is, I can see the entire wide field of vision inside that is behind the car or behind the vehicle, and I can easily analyze the traffic, what it is behind the vehicle. So that this image which is formed here, when compared to the object, will be of full size. What size it is there? It is the full size of that, but it is diminished. A small size of that, but a full size image of the object which is behind my car can be seen inside the mirror. So therefore, these mirrors are being used as convex, that is rear view mirrors. So we will go with the simple thing, simple media we will use, and try to understand this. So here you can see, this is the plane mirror. So very narrow range is there of vision, very narrow vision is there for plane mirror. Instead of that, if you use a convex mirror, so wider field of vision can be seen here. So wide view angle is visible. So by using a convex mirror at this point. So this is the field of vision in plane and convex mirror. So instead of in the car or the vehicles, instead of that is convex mirror, if you use a plane mirror, the field of vision will be very less. So in a plane mirror, if you want to see the full size of the object, the size of the mirror should be half of the size of the object. If you want to see my entire image in a plane mirror, then the size of that plane mirror should be half the size of the object. So if you want to place it in a rear view mirror of a vehicle, then the mirror, using plane mirrors, if you make a rear view mirror, the mirror becomes very big. So that doesn't suit to the vehicle. So therefore, instead of that, we are going to use a convex mirror, which gives a very big object is there in behind the mirror. The image of that particular object inside the mirror will be of full size, but will be diminished. And moreover, the other areas which is beside, in and around the object can also be seen, because the image is made diminished and full size. That's very important. Diminished and full size, and also other advantage is it is erect. It is erect. How the object is, same image you can see inside the rear view mirror, and wider angle of vision is available. Right. So going to the next one. So this is convex mirror used in vehicles. See here you can see the rear view mirror. So inside that you can see the image of the traffic behind the car. So here the car is very big, actual size of the car is very big inside behind the vehicle, but the image of that particular object can be seen as a very small object because due to this concept which is happening inside the mirror here. So you can see another rear view mirror there. So it is entire view of the road which is behind the vehicle can be seen in this. So in this it's very clear. You can see the cars or the traffic which is coming behind us. So here the images you can see, they are diminished, they are virtual and erect because the image is formed behind the mirror. So we can easily see the easily see the images, small size images of the objects. So convex mirrors are widely used as rear view mirrors in automobiles and vehicles because it can diverge light beams and make virtual images. See, this is the same ray diagram what we have drawn here. Actually, another light ray is taken at some point on the mirror. It's okay. You can take the second light ray at any point on the mirror. I have taken to the pole. He has taken to some other point on the mirror. It's okay. Same image will be formed. So object can be placed at any point in front of the mirror. It doesn't count. Any point. Okay, another use is convex mirror used inside buildings. So for example, it's a very big building, it's maybe a mall or some concert hall or whatever it is. So if a person is sitting at a particular point, the owner is sitting at a particular point and he wants to see the entire hall in a single view. So to his convenience, he can fix a convex mirror so that the entire image of the hall will be inside the small mirror where he can get the wide view vision of the entire hall. So if any particular customers, they come inside the hall, they do some activities, he can easily watch, and the workers in his shop or mall, he can watch them by using that is convex mirrors. It's very easy. So here you can see that. So it's in the parking lot, so it can be used on here. For example, you are going in a road, some other road is there which is perpendicular to your road. So at that end, at the diagonal end, they will fix a convex mirror so that when you are going, if you see the mirror, you can get the images of the vehicle which are coming in that road, so that you can avoid accidents. Suddenly if a vehicle comes, it may result in accident. So if you are going on the road and if you see the mirror which is fixed at the diagonal end, so you can also see the vehicles which are coming from that road. So that can be, we can prevent accidents using convex mirrors. Okay. Next one. So this is what I told you in that is malls. See here you can see this round that is a convex mirror. This is also a convex mirror. See the very large area, including the person. A very large area is being covered, so which is diminished and virtual. Right? So here also you can see that so many people are here. So a person standing here, so many people, including them, you can see inside the mirror because the images formed in the convex mirrors are diminished, virtual and direct. Okay. Next one. So here convex mirrors are also used in various other places like street light reflectors, as it can spread light over large areas. So it's very simple. So it's a bulb if you consider that, and if you consider this as a convex mirror, the light rays coming from this source of light, when they fall on the mirror, they get reflected. Maybe draw it like this. So they get reflected, light rays gets reflected at various different angles. So you can get a large area of vision. So small bulb can be used to light up a very large area of land or place by using convex mirrors. Okay. Next one. This is the dome above the buildings. So it's a very important one. If a very big building and a very big concert hall is there, at the top of the roof you can fix a convex mirror. So at the center of the convex mirror, if you fix a big bulb, so the light rays coming from the bulb, same thing here. The light rays coming from the bulb are going to fall on the mirror, and they are going to get reflected, and they cover the entire hall. So this can be used for also for making telescopes at a particular scientific instrument. and ceiling dome mirrors. So this is the one of the use. Okay. So these are the uses of convex mirrors. Among all the uses, the most important uses, convex mirrors are used in making rear view mirrors. Why? They are going to ask you as a give reason in your examination. Give reason, or why convex mirrors are used in making rear view mirrors. Give reason. So this is the thing. So this is the scientific reason behind that. The object is here. Inside the mirror, it appears the object is formed, the image is formed here, which is same, that is full size of the image is formed, but diminished and erect, and which is a virtual image. So this is the thing you have to remember. Alright, so we'll go with a very simple concept, next concept, that is the image formations, that is the mirror formula, which is very important. We'll go with that. So now, imagine a concave mirror. This is the concave mirror. This is the pole. We'll take this as the principal axis. This is the pole of the mirror. This is the center of curvature. This is the principal focus. That is represented by F. Okay. So here, if the object is kept at this point, AB, let us consider AB as the object. An object is kept in front of the mirror, which is beyond C. What we know that. So here, this is, we know the Cartesian sign convections, what we have discussed in the previous class. Cartesian sign convections we have discussed in the previous class. So here, AB is the object. The size of the object or the height of the object will be considered by a symbol, that is H. H becomes the height of the object or size of the object. So whatever we mention is, whether it is size of the object or height of the object, both are one and the same, no confusions. So the height of the object or the size of the object is represented by the small letter H. Now, if you keep the object, in case of a concave mirror beyond C, the image is formed between C and F, maybe here, between C and F the image is formed. Okay. Now, if you consider this as A dash and B dash, this is the image formed. The height of the image or the size of the image is considered as H dash. That's the symbol for representation of the height or size of the image. The height of the object is taken as H. The height of the image is taken as H dash. You have to remember. You have to remember this. So object height or object size is represented by small letter H. Image size. Image size is taken as H dash. H dash represented by the symbol H dash. Now, here whatever we measure, whether we measure the distance of the object from the mirror or the distance of the image from the mirror, both are measured from the pole of the mirror. That is from the pole of the mirror, that is this point. So now, if you draw a tangent at this point, if you draw a tangent is a line which touches the circle at one and only one point. So this line is called a tangent to this circle, because I call it as a circle, mirror as a circle, because it's a part of a hollow sphere. Therefore, I call it as a circle, part of a circle. So if a straight line touches the circle at one and only one point, then it is called a tangent. So why we are drawing a tangent here? Because to take the reference, that's all, nothing more than that, just for a reference. So here, the distance between the pole of the mirror and the object, the distance between the pole of the mirror and the object is taken as, that is this distance we are going to take it as U. The object, the distance of the object from the pole of the mirror is represented by U. You have to remember this. This is object distance. So object distance is U, represented by U. Now, the image is formed here. At this point, image is formed. The distance of the image from the pole of the mirror or from the mirror is taken as, this distance is taken as V. small letter v. So this is image distance. Image distance is taken as v. And now the focal length, that is the distance between the principal axis, that is principal focus. This is the principal focus and the pole. So this is taken as the focal length. So focal length, we know this. Focal length is taken as small letter, represented by small letter f. So this numericals you have to remember here. Object size is h, size of the object, or height of the object. Both are same. That is represented by h. This is image height of the image or size of the image, that is represented by h dash. The distance of the object from the pole of the mirror is represented by the letter u. The distance of the image from the pole of the mirror is represented by v. So here we have to go with some sign conventions in this case. So now here whatever we measure we measure it from the pole of the mirror, and if that measurement is against the direction of the incident light rays, if that measurement, what we do is against the direction of the incident light rays, then it will be taken as negative. And if the distance what you are measuring is along the direction of the incident light rays, then it is taken as positive. That is sign conventions I have told you earlier. Whatever you measure above the principal axis, that is considered as positive, and whatever you measure below the principal axis, that is taken as negative. So here, in case of a concave mirror, let us go with the things now. Now, height of the object, that is h. As we are measuring this height above the principal axis, therefore height is positive. This is plus h. This is positive. So no need to write plus h. It is understood that is plus h itself. Okay. Now we will go with the image height or image size. So this height from b dash to a dash we are measuring, and this measurement is done below the principal axis. Therefore image size in this case will be negative. So it is minus h dash. You should remember this. Now we will measure the object distance, the distance of the object from the pole of the mirror. Now the light rays are coming in this direction, and you are measuring from here to here against the direction of light rays. So therefore the value of u, what you take in case of a concave mirror, you are doing that measurement in the direction opposite to that of the incident light rays. Therefore that should be taken as negative. So object distance is minus u. Now image distance. So this is the image distance what we are taking here. So here it is to be measured from the pole of the mirror. So from here to here you are measuring. In this direction you are taking the measurement against the direction of the incident light rays. So therefore the value of v also becomes negative. So it is minus v. Now regarding focal length, so it's very important. It will be asked for 1 mark. So in case of a concave mirror, the focal length is measured from the pole of the mirror to the point where the image is formed, or that is the principal axis. The distance between the pole and the principal axis is measured in this direction opposite to that of the incident light rays. Therefore f, the focal length in case of concave mirror is minus f. See, these are the very important things you have to remember. Very important. So here in case of a concave mirror, object size is positive, image size is negative, object distance is negative, image distance is negative, focal length is negative in case of concave mirrors. Now let us go with convex mirrors. Okay. So this is a convex mirror which is silvered inside. So this is the principal axis, this is the pole of the mirror, this is the center of curvature, this is the principal focus. Now let us imagine a light ray is incident on the mirror it is going to get reflected and move through some direction, but as though it appears the light ray is traveling from the principal focus. Now, here, in case of a convex mirror, we cannot place the object inside the mirror, that's not possible. So we have to place the object in front of the mirror itself. Therefore, I will take this object as, I will place it in front of the mirror and call it as AB. So now, let h be the height of the object. So, object size or object height. Object size, we will take it. So, it is, object size is, as we are measuring above the principal axis, so its value will be plus h. So now let us imagine the image is formed between P and F somewhere here. So we know that in case of convex mirrors, images are virtual, erect and diminished, which is formed behind the mirror. So this is the image form. Let us take it as A dash and B dash. So now, so this is the height of the image or the size of the image. So this is h dash. So in this case, image size or height of the image is taken as plus h dash. So why means because here we are measuring this height above the principal axis, therefore it is taken as h dash, that is plus h dash. Okay. Now we will measure the object distance, that is u is the object distance. We can draw a tangent at this point and do whatever the things we did there. Okay, no problem. So light rays are incident in this direction and you are measuring in the direction opposite to that. So the object distance is taken as negative, that is minus u. Minus u you have to take because you are measuring in this direction and the light rays are coming in this direction, therefore it is negative. So now we will take image distance. Image distance. So now, light rays are moving in this direction towards the mirror. In this direction, the light rays are moving out. So from pole to the object, you are measuring in this direction. That is V. V you are measuring in this direction. Therefore, you are doing this measurement in the direction of the incident light rays. Therefore, it should be taken as positive. So it is plus V. It's very important what I am telling you here. Now let us go with the focal length. So it is the distance between the pole and the principal focus, and this value of f, which is in between pole and the principal focus. As you are measuring from the pole to the principal focus, you are doing it in the direction of the incident light rays. Therefore, focal length we will take it as, it should be taken as positive. So focal length of a concave mirror is negative and the focal length of a convex mirror is positive. So these are the things which are very important. You have to remember this, right? I am sending you notes already. I have sent you the notes in WhatsApp. Please go with the notes, be updated, write down the notes, read it the same day, understand the concepts. If you do not understand or get confused at a particular point, please call me and clarify. No doubts should be carried further, right? So in this session we have come across a lot of things. One is the ray diagrams connected to convex mirrors, uses of convex mirrors, and the main difference between concave mirrors and convex mirrors, and the sign conventions which we will be using. This is very much required because we have to solve a lot of numericals on concave mirrors and convex mirrors. So you have to remember this, make a note of this. This plays a very important role. Understand the concept. Once you understand the concept very well, you will be able to very easily solve all the numericals on mirrors. So in tomorrow's session, I will be going with mirror formula, magnification, and magnification of concave mirrors. So these three topics will be covered in the next session. Until that, stay home, stay safe, and keep learning. Thank you.